Hey guys, welcome back to another video. In this video, we're going to be working on Leetcode problem number 17, in which we have to create a letter combination from a phone number. So without further ado, let's get into it. So given a string of digits, 2 to 9 inclusive, we want to return all possible letter combinations that the number can represent. We see they gave us a picture of the mapping of the digits to letters that would be like on a telephone. So 2 maps to ABC, 3 maps to D, F, and so on all the way to 9, which maps to W, X, Y, Z. And looking at the examples they gave also, we see an example such as 23 would return AD, AE all the way to CF because we loop through all the letters in mapping to the 2, which is ABC, and correspond them to or pair them with the letters that map to 3, which is DEF. And so we can create a bunch of combinations through that. If the digits is of length 0, we're going to return an empty array. And if it's of length 1, we're just going to return the letters that map to that single digit. So without further ado, let's start thinking about how we can go about answering the problem. And so one thing we want to do is, given the example that they have, let's try to think about how we can solve it, or if we were doing it on our own. So if we're given 23, we know that 2 maps to ABC, and we know the 3 maps to DEF. And so what we have is we know that the 2 is A, B, and C. And so now, since we list out everything in the 2, we want to list out and pair it with things with letters in the 3. So first we're going to start with the first letter, and we're going to loop through the letters inside the 3 and pair them with A being the first letter. So what I mean by that, we're going to have AD, AE, AF, and so those are going to be the 3 letters corresponding our letters in 3 to A. And so now we do the same thing except with B being our first letter. So we're going to have BD, BE, I believe it's BF, and that's with B being the first letter. And then we're going to have CD, CE, and CF. And so that's how we can get that array of all the combinations. What we want to do is we want to loop through each letter iteratively and pair them together as we need to. So another example I think we should go over is if we have more than 2 letters. So we have 2, 3, 4. So we know that 2 maps to, sorry, that's terrible apostrophe, maps to ABC. We know 3 maps to DEF. And then we also know 4 maps to GHI. So how do we loop through? We do the same process. We're first going to list out A, B, and C. And so those are our letters in A. And then we're going to start iterating. We're going to start at the A here. And so we're going to have A. And now we're going to loop through the letters in our DEF. So the first letter there is a D. But then one thing we also need to remember is that we also have another layer where we have to loop through the letters in 4. And so before we loop through the letters in 3, we have to loop through the ones in 4 first. So we're going to have ADG, ADH, ADI, and that's going to be all the letters mapping A and D to the letters in 4. Now we do the same thing, A still being our first letter, except now that we're done with the D, we're going to move on to the E. That's going to be AEG, AEH, AE, I believe it's I, and so that's with the E. And then once we're done with that, we loop through with the F. So we're going to have FEG, FEH, FEI. And so, oh, sorry about that. I actually did that wrong. This should be, A should still be our first letter, except we have F being our second letter, A, F, H, A, F, G, A, F, I. So all this is with A being our first letter, and we're going to do these 3 more times, so, or actually 2 more times rather, where our B, that's a little glitch, our B and our C are the first letters in. So we do the same thing, we loop through the 2, we loop through the 3, and then we loop through the 4, and we keep adding on from there. And so that is kind of the thought process that goes behind appending and pairing all the combination of the letters. And so having this in mind, we can kind of go into our program and try to code it up. And so I actually have it open over here. And so the function, I believe, is called letter combinations. And we get a value of digits. And we want to return our combinations. So one thing you should notice is that since we don't know the exact number, the exact length of the digits digit string that we're getting, it could be two letters, or 2 numbers, 3 numbers, 5 numbers, we don't know. We're gonna have to use this concept of recursive function, where we call a recursive function on of itself, so that it can iterate as many times as it needs to. And so it's more of a dynamic program as opposed to hard coding values in. And so I think you'll understand as we go along what the usefulness of having recursive programs. But looking at the problem, the first thing we should probably take care of is creating a dictionary that holds the mappings of the numbers to the letters, because that's something we're going to have to use often. And so I'm going to call this num letters mapping. I'm going to quickly fill it in. The 2 maps to ABC, and then 3, 4, 5, 6, 7, 8, 9. And so that's going to be R9, R8, R7. Sorry about that. R6, R5, R4, and R3. And this maps to DEF, GHI. What does the 5 map to? JKL, JKL, MNO, PQRS, TUV, WXYZ. So these are our mappings. And actually, even before we do that, let's first handle our base cases within here. Base cases. So the first base case is if len digits is equal to 0. We're going to return an empty array. And then our second base case, if I can, is if the length of our digits is equal to 1, in which case we want to return 4 r is equal to here 4 letter in num letter mapping. So we're going to loop through, we're going to access the key, dictionary. And what do we want to pass? We want to pass in the first letter of our digit string, which is going to be accessed with digit 0. And we're going to say r.append letter. And then we're just going to return that array. And so we loop through all the letters inside that one, all the letters mapping to that one number, and we're appending it to our array, and then we're just going to return that at the end. And there is a shorter version to do this. We could say something like val for val in num letter mapping digits 0. And so that's kind of a, I guess, one-line version to do this, but this other version is a little easier to see. And so that is that's how we can just handle both of our base cases. Now I mentioned that we're gonna have to create use recursive functions to solve this. So I'm actually gonna go ahead and create this right here, or at least call it. So what do we want to pass in? We're gonna want to pass in the remaining digits we're working with. we're gonna want to pass in I'll quickly create it actually. Sols, which is gonna hold our all the possible combinations, and then we're gonna pass in num letters mapping because we're often gonna be using this dictionary, so it's important to pass into our function. And so this is gonna house this is gonna house the pairings or combinations. And then at the very end, we're gonna, within a recursive function, we're gonna have to have base cases. And so when our recursive function gets to a point where we don't have any more digits, we'll just return our sols array at that point. And so I'm actually gonna first create our LC, or at least set up our LC helper here. So we're gonna have digits, sols, num, letters, mapping. Now, in order to think about what we need to do, add, the first thing we have to do is we want to map through every single letter in one digit and add that to our sols array in our first iteration. And so I'm actually going to handle this iteration inside the letter combinations function. And so what I mean by that, I'm going to say for letter in num letter letters mapping. I actually realized here there should be nums letter mapping where we pass in digits 0, the first letter. We're going to say sols.append letter. And so now that we have this array pre-populated with the first letters, let me kind of explain the thought process. So we saw earlier that we want to take each letter and we want to be able to add to it as we need to, right? And so one thing we can do, a slight different way we could do this, if we're looking at something like 2, 3, 4, if we're looking at 2, 3, 4 again, we can have our sols array pre-populated with A, B, and C from the first from the mapping. And so once we've done this, when we call our function, the next thing we can do is, since we're done with this, we're looking at the 3 now. What we can do is we can create a new sols. I'm just going to call it sols array again. We can loop through every letter in the original sols array. I'll call this new. We can loop through every letter in this original sols array, append or map all the letters in our current number to that letter from the original array, and then append it to our new sols. And so what I mean by that, I can call this A, our 3 maps to DEF. So we're going to have AD, AE, AF, and then we're going to have BD, BE, BF, and then we're going to have CD, CE, C, CF. And so this is kind of our second iteration. We loop through the 2, we loop through the 3, and now what we can do is, now that we're done with the 3, we're working with the 4 now. And so now that we have this new sols array, we can pass that into our recursive function. I'm going to call this new sols2. And now we have all these strings in our previous original array. Now all we need to do is we need to map through all the letters inside of the 4 and basically add them to our original letters. And so that means we can get AD, I believe it's G, AD, whatever it is, H, ADI, and then we're going to have AEG, and so on until we get to the last iteration where we get C, where we have CF. Then we can do CFG, CFH, CFI. And so this is very similar to the process we were talking about earlier, where if we look over here, what we were doing was we would look at the A first, then we'd look at the D, and we'd only look at that first letter, and then we'd map all these letters in the 4 over here when our A and D were constant, we mapped all these letters in the for to the A and D only. And then we did the same thing with the AE, and then we did the same thing with the AF. And so this is a very similar process where instead we're storing the AD, the AEs, the AFs, we're storing those inside of an array, and then we're looping through each one, and we're just adding or mapping our new letter to that original string, I guess you can call it, that was set in that array. And so it looks a little bit different, but the concept is very similar. And so that is kind of the idea. And that's also why, if we look at the code, I pre-populated our sols array with the first initial letters so that we can go from there. And so the first thing we should actually do is we should return the rest of the digits array. And so actually, let me just type this. So what this does is digits 1 colon, what it does is it returns everything from the first index onwards. And so, for example, if we're working with something like 1, 2, 3, if we want to return 1 colon, we're going to return 2, 3 then. And so that's all that does. And so that's like, it's kind of a useful thing that might help. And so now that we have done that, our sols array is pre-populated with all the letters mapping to the first number. And so now we want to say, first we want to check to see if len digits is equal to 0. If it is, we're just going to return sols. And so this is going to be the base case so that we don't go on forever. Now I'm going to create a new array called new sols. And what I'm going to say is for sol in sols for letter in num letters mapping digits 0 new sols dot append sol plus letter. And so what this is doing, this is very similar to what we were talking about before, where we loop through every element inside our original array. We loop through every element inside our original array, which in this case was passed into our function as an input. We loop through everything. We append the letter that we need to. We can see over here we appended the D, the E, the F from at this point our 3 was the first letter in our string. So we mapped all those letters to the original string that we were given, and then we looped through every single string and mapped all of them as we need to, and then we return this new sols at the end, or pass it in as a function if we need to. And so same thing over here, we looped through all the originals and mapped or added on whatever letters we needed to that map to our first number at that point in the string. And so that's what we're doing here. We're looping through every string in our original array. We're looping through every letter inside of our new first number that we have since we returned digits 1 colon. And then we're just appending the sol plus the letter. And that is how we can add the new letter that we need to. And then at the very end, we want to return lc helper, where we're returning digits 1 colon. We are returning our new sols so that in our next iteration we have a new set of strings to work with. And we're obviously gonna leave the dictionary or the mapping alone so that we can keep using it. And so that is how we can code up the function we've handled for creating dictionaries, base cases. Hopefully there's no naming errors in this. I guess we'll find out when we run the code, but that's easy to fix, of course. We created new arrays by mapping our letters to the original strings that we were given in the array. And when our digits length is equal to 0, we return our final array that holds all of our combinations. And so what I'm actually going to do is I'm just going to print letter combinations. And so this is actually the test case that was given inside of the test case over here, inside of the example. And so I'm actually going to copy and paste all this. and paste it right here. And so what this does is it will tell us if, hopefully, the arrays are the same. And in addition to that, I'll actually delete all this. So we'll have two outputs. We'll have one output that'll list the array, and then our next output that will tell if our array is equal to the answer. And so if we run our code, hopefully it should work. So it does. We return true, and so this means that the array that we have is, or the array that we returned is equal to the answer array that we're supposed to have. And so I'm going to go into my code, and I'm just going to copy and paste this into the Leetcode editor that we have. And so Control C and copy and paste that right here. And we are going to have to change a slight bit. Self needs to go over here since we are working within a class. And then self needs to go here, and we need to call a self over here as well. And so let me run the code to make sure that we copied everything correctly. Indentation error. Oh, we don't need to copy this. I guess I actually copied this over. Okay, now it should run properly. Yeah, run the code, and okay, so it ran the test cases that we wanted to. I'm gonna first run to an empty array, run those again really quick just to make sure that those examples 2 and 3 work as well. So they do. And now I'm going to add a few test cases of my own. I'm going to try 1, 2, 3, or actually not 1, 2, 3, 2, 3, 4, and then we can also try 2, 3, 4, 5. And so if we run our code, hopefully that should pass all those test cases. So it does. So that's good news. And obviously the 2, 3, 4, 5 returned a huge array, but that's just mapping that, like we saw before, is just iterating over all the levels and adding whatever we need to. And so I'm just going to hit submit, and hopefully it'll also pass all the tests in Leetcode. So it does. This is how we can code up our function to translate digits into letter combinations. Hopefully this helps you guys, and see you guys in the next one. Alright, later.